Overlays are a technology that are being used more and more inside of our data centers every day. Overlays rely on your traditional network, but then build a virtual network on top. The benefit of this technology that we normally see is to provide network access in places where we couldn't normally have it. So for instance, if I want to provide my layer 2 connectivity across data centers that could be in different geographic regions or even across multiple states, normally there'd be no way to run the dark fiber to allow that connectivity to happen, or if we could, it would just be way too cost prohibitive. So with an overlay, I can create a virtual connection or a virtual network to allow me to share layer 2 between two data centers that are geographically dispersed. I can also use overlays in my own network to reduce protocols like spanning tree. Typically in the past, if I wanted to allow workload mobility in my data center, I had to share a layer 2 VLAN across my entire infrastructure inside my data center. This can be problematic. Anywhere that I extend layer 2 opens me up for network outages due to spanning tree recalculations, due to misconfigured ports, due to broadcast storms, ARP storms, things of that nature. If I can reduce the amount of spanning tree in my environment, but still allow workload mobility over layer 2, that sounds like the perfect solution. And in this case, I can do that with an overlay like VXLAN or NVGRE. I'm relying on my high-speed, reliable layer 3 network underneath, and then I can use VXLAN or NVGRE for my overlay inside the data center, mimicking the same functionality that I had with spanning tree without having to spread spanning tree everywhere. Recently, some of my layer 2 overlay technologies have migrated into kind of a hybrid layer 2/layer 3 overlay and offer the best of both worlds. How we've seen these overlays evolve over time is that we used to use functionality like VPLS or MPLS to give us our data center interconnect. The problem is that you pretty much had to be a rocket scientist to make that work right. And it still opened you up to a lot of fate sharing between data centers. Cisco came out with OTV, which made data center interconnect very easy to implement, as well as the fact that it had a ton of protections built in to allow you to reduce the amount of fate sharing. Inside of our data centers, we've seen an evolution from a 3-tier network down to more of a 2-tier or even a spine leaf fabric. That started with Fabric Path and has now moved forward with the standards-based protocol VXLAN, which is what a lot of my customers are moving to, whether that's with ACI or whether they're building that type of network on their own. But VXLAN allows us to have workload mobility inside of our data center, get the robustness of a layer 3 protocol, but still be able to share layer 2 where we need to. Please join me for the next lesson, 7.4, Understanding OTV.